Well, I tell you, it was running really, really bad. Bucking, surging, misfiring. Sounded like 4 or 6 cylinders misfiring. All I did was mess with the EGR valve, tapped a little bit, boom, popped off. It's running like a top. We need to get this into Tech Garage today and diagnose and check out why this thing's running so bad and get it right. Welcome to Tech Garage, presented by RockAuto.com. Well, I pulled the Mustang up to the shop and it was running horrible, man. It was shaking, bucking. Thought it was a misfire. Started messing with the EGR valve. Bam, popped off. Started running like a top, Brian. Possibly an EGR problem?
I'll tell you what, I think your instincts were spot on. I just got a P0401 code, which means a low pressure differential within the exhaust gas recirculation system, so I think we're onto something.
Yeah, it explains a lot. You know, there's a couple tests you can run right out in the driveway. You got a vacuum system like this with a vacuum EGR. First thing you want to make sure is you have source vacuum, but a big misconception, you don't want source vacuum at the EGR because the computer will control that through a solenoid. So I want to make sure it's down here at the solenoid. I'll pull that off and check it. And then what I can do, Brian, is I can actually pull this off and simulate this thing opening. It should run like it was running out there. Still running pretty bad. It may be hung up a little bit. Let's see what happens.
Well,
crank it up.
And Fords are famous for this, right? So let me give you just a little bit of vacuum. You ready?
Yep, crank it up, clear. Great, so we got it running now. I'm just gonna unplug the vacuum source going to it, and then I can hook it up right there. And then what we should be seeing, and we do, is we're actually looking at source vacuum, anywhere from 16 to about 22 inches of mercury. This one's at 15. We're in good shape there, so I could plug that back in so we don't have a big vacuum leak. Now the cool part is Rock Auto supplied me with this vacuum gauge along with this vacuum pump. Now I can take this vacuum pump and I can put it right across the EGR valve itself. Now when I do that, I should be able to pick that up. Wow, and you can hear it. That's exactly how it was running outside. So EGR open, EGR closed. So that's a good indication that was the problem. Go ahead and cut it off, Brian. Now those two tools, like I said, rockauto.com, great diagnosis, no problem with it. Brian, it definitely pop it open and pop and close, and it was running just like it was in the parking lot.
Makes all the sense in the world. The symptoms line up. So I'll tell you what, why don't I get started taking that off? We got all the new parts we need here from Rock Auto. We talked about the vacuum lines, the importance of good vacuum flow. We might as well replace them while we're at it.
Yep.
Not terribly hard to do.
And that's the cool part, the EGR, and I also got the hoses because it's a real common problem with these Fords. It goes down to this difference in pressure valve right here. It actually goes down to the exhaust manifold, so I'll get started on those. But before I do, let's talk a little bit about EGR and what EGR is. Well, it's exhaust gas recirculation, exactly what it sounds like. I'm taking exhaust gases and I'm putting them back into the engine, which is an inert gas. They're not burning, and I'm creating a controlled misfire. Well, why do we want to do that? We're actually reducing engine temperatures and reducing NOx, oxides of nitrogen, when it comes to emissions. So that's pretty cool. And you can see it on this graphic. You can see it coming here from the exhaust. It comes out, and then right above the exhaust, that's the EGR valve. And then what happens is that EGR valve at given times, not at an idle, that's not good, but when we're going down the highway called a drive cycle, it's actually going to open, and it's going to allow some of this inert gas to go back into that cylinder, create a controlled misfire, lowering those cylinder temperatures. Now you can see all the parts right here on the Mustang. The EGR valve starts right here. Then we go over to the solenoid valve. The solenoid valve is what allows it to go into the actual EGR valve. And then Brian mentioned earlier, this is the DPIFI valve, a difference in pressure feedback. And this is the EGR system right here that actually reads when it opens and closes, it looks at the exhaust. So it's pretty cool, Brian. Wow, you got that off already?
Absolutely, got it off already. Now, this is interesting because you can't visually see anything wrong here, but clearly with the test he ran, that plunger is ineffective and not working. It's failing somehow. Now, other interesting symptoms, things that can happen when you have a bad EGR system, the vehicle will start running rich, and the computer's constantly trying to compensate. Everything runs hotter. You can foul the plugs and actually get a lot of carbon on your plugs. Your catalytic converters, the honeycomb, gets hotter inside that. A lot of bad things happen when you don't have that balance.
That's for sure. Now what I'm going to do is I'm going to go ahead and replace these hoses right here. You already got the EGR valve off, no problem. Now this is a vacuum actuated system. There's plenty of other systems, and we'll take a look at them all right after this break. There's plenty more. Tech Garage presented by RockAuto.com.
Tech Garage, presented by RockAuto.com, is brought to you by Zumbrota Drivetrain, remanufacturing redefined. Brand new muscle car, building yesterday's dream cars today. And by RockAuto.com, all the parts your car will ever need.
Welcome back to Tech Garage, presented by RockAuto.com. Now that we understand EGR, exhaust gas recirculation, and what it does, let's look at the evolution. It all started right back here with our Mustang, which actually had a vacuum actuated one. We saw when we pumped it up, the engine started running rough. Something I should mention, if you pump it up and it doesn't run rough, probably the diaphragm's leaking and it's not working at all, so you have to replace it as well. Now this thing is actually monitored by the computer by this differential valve, this difference in pressure regulation. It's an EGR system. So what happens when it opens up, you get this huge void in the exhaust of exhaust gases, and it senses that. Now some cars use a MAP sensor, a manifold absolute pressure sensor. Same thing, when we open this up, we're creating this big hole in the exhaust going into the intake. It changes pressure in the MAP sensor, the intake manifold, and it can tell if it's working or not. Kind of a tough thing to diagnose for the car, but we did a good job on ours. Then Ford actually went to this one right here, which is just the same thing with everything built into one unit. A lot of misdiagnosing going on with these guys, so they put it all together here. You can see the actual valve, the solenoid, the differential valve, and the EGR in one small package. Then we went to what's called a digital EGR valve, and this is pretty cool. You've probably seen this on a lot of cars. This digital EGR valve right here uses 3 different solenoids, so it can do 33%, 66%, or 99, almost 100% EGR, depending on the car and the needs and what's going on when we need EGR or not. And this is cool because I can show it to you in action. So if I come over here and I click this to the battery right there, watch this guy right here. You see this? Now it's going up and down because that's 33%. Now that would put a little EGR valve gas in there, not a whole lot. I can do the other one, puts that one in, but the computer, if I can get these 2 wires together, would do them together. Now that would be 66%. EGR gas is going in there, cooling the cylinders. Well, how does it do that? Well, it's a misfire, so there's a lot of raw fuel in there, and that raw fuel is cooling the cylinders, and it's reducing that NOx. Now I can't get all 3 wires in my hand, but it would open up all 3 and cause 100% EGR. It would run pretty rough at that point, but boy, it would sure cool the cylinders. This one right here, this is a linear EGR valve. That's the next step. Now this one here, the computer can move it at gradual steps wherever it wants it. So we got a lot more precise control when it comes to that exhaust gas recirculation or the flow of that inert gases going back into the cylinder. Linear EGR valve. Well, you probably went out to a new car and popped a hood, no EGR valve. Well, what's going on there? That's pretty cool. In an episode a season ago, we actually looked at variable valve timing, and this engine has it right here. Well, what does that have to do with EGR? Well, watch this. What happens is we're moving the timing back and forth, so we can actually move the position of the camshaft. If we can move the position of the camshaft with the timing, what happens then is we can create what's called valve overlap. We can actually just close the valve a little early, keep that inert gas in the cylinder, bam, there's your lower temperatures, there's your EGR, you don't even need a valve. Pretty cool look at the evolution of it, but we need to check in with Brian and make sure our Mustang's running primo.
One final check, we got the new vacuum lines installed all the way down to the exhaust manifold. They're connected well down there and up out of the way. So, next step is we're going to take this new EGR valve, install it. We've got, of course, a new gasket we also got from Rock Auto. Very simple to do. You want to make sure the surface, mounting surface here is clean, no carbon, no burrs. We're good there. I'm going to take the exhaust gas feed and reconnect that nut first. There's not as much flexibility in that line, so it's going to actually make this a little bit easier. We're reusing the original bolts, but be really careful not to strip anything here. Most of these are magnesium, alloy, and aluminum, so it's really easy to strip. Take your time here. And I'll tell you what, you may need a torque spec to follow, but we're really close to our test drive.
Yeah, we are. And what we want to do is we actually want to verify the customer's concern. A couple steps there. Take the scan tool. You want to go in there and clear the code. Brian, nobody likes driving around with a check engine light, so turn off that light. And then the test drive, well, not so much like normal. A test drive for an EGR, there's some enable criteria the computer has to meet. I know that's a big word, but look at this graphic right here. It's called an OBED2 drive cycle. And you can see it's not running at idle. That wouldn't be a good thing. So it's running really at Excel, 55 miles an hour, 20 miles an hour with the clutch depressed and up 3/4 throttle. So really it's an intrusive test. It's putting that inert gas, causing a misfire, but the computer doesn't want you feeling it. So just take it on a nice test drive, maybe out on the highway, come back. If that check engine light's not on, you're good to go.
Absolutely. Very simple to do. And again, follow torque specs here if your vehicle calls for them. This thing's going on nicely. We got one more vacuum connection to make, and I think we're ready, buddy.
Hey, we're good to go. And you know what? You want to stick around because the Garage Ed segment, we're talking about electrical diagnosing and we're talking about protection devices. We're actually going to burn a fusible link. Man, it's going to be a smoking segment, so stick around. There's plenty more Tech Garage presented by rockauto.com. Welcome back to Tech Garage, brought to you by rockauto.com. Now, one of my favorite segments, Garage Ed. We know the basics now, voltage, amperage, and resistance. Let's talk about some circuits, fuses, and protection devices. Now, I went to rockauto.com and got all these protection devices right here so we can take a look at them. You could have a fuse, you can have a circuit breaker, or you can even have an older car. They have parts for that as well. These are the old glass type fuses right here. Now, fuses, they come in shapes and sizes as well. You can see actually the mini fuses right here, the regular fuses, and then the maxi fuses. Now I'm going to look at the circuits, and we're going to go through each one of the circuits. The first one I want to look at, well, that's a series circuit. Series circuit, think about that inexpensive Christmas lights on your tree, you know, where one of the bulbs are out and then you're there for 4 or 5 hours trying to figure out which one it is. Why is that? Well, there's one path of flow. If I pull this light bulb right there, the whole circuit goes dead. That's a series circuit. Now, our protection for the series circuit is an actual fuse. It's located right here. And I want to talk about some bad circuits, some shorts. Now, you can look at this first graphic, and this one's called short to power. I like to think of that as like copper to copper, maybe wire to wire. That graphic shows it where opponents can do some funky things. Maybe they come on, maybe they don't. Maybe you turn the radio on and the wipers work. Now, this other graphic, this is short to ground. That's a dead short. Now, that graphic, we're going to do that on our board, and what that's going to do, it's going to cause the amps to run so fast that it's going to create heat and it's going to blow that fuse. So what I'm going to do is I'm going to use this big wire because I want to be a lot stronger than that actual fuse. And if you keep your eye right here on this fuse, I'm going to hit this. And when I hit it, 3, 2, 1, instantaneously, that thing popped. Now we have a maxi fuse right here. You can see that was 40 amps. That took a little heat, but that joker there, it burnt in half. Now you never want to do that also with this. You want to use a fuse jumper wire. If you're going to make any jumps, I went ahead and I built this fuse jumper wire using a little mini fuse, so you're protected. I'm actually faulting these circuits. Now I come over to the next one here. This is a parallel circuit. This is pretty cool because if I hook this up, think about that good set of Christmas lights. Maybe spend the extra buck. What happens when you pull a light out, the other one burns. Why? 2 paths for current flow. They're equal. So they each drop 12 volts down each branch and they each burn. Now I got a circuit breaker here. This is really cool because I can come to the circuit and I can go right across it and I can short it out. Now this is a resettable device. So watch this. When you hit it, the lights go out. And then we're waiting. It's closing. Once it closes, bam, the lights come back on. Last circuit is actually a parallel circuit, series parallel. Pretty cool because we have a switch in series here, which I can dial up and down and change the brightness of the lights. And then we have the parallel portion right there. Same as the parallel. I pull one light bulb out, the other one stays lit. The only thing different, we have a switch in series. Now this one, we have a fusible link. That's 4 wire gauges smaller than the wire it's protected. Remember, wire gauges, the higher the number, the smaller the wire. So this one here, I'm actually going to go across the circuit right about here. Grab this, I'm going to hang on to it, I'm going to short this and watch this guy here should burn. Woo, and there it goes. Well, I'll tell you what, that worked really, really well. I'm going to head over and check out some of the circuit devices that Tom has on rockauto.com and give the smoke a chance to clear. I always go to rockauto.com. I'm getting brake pads, struts, but fuses, circuit breakers, all that there as well. Tom, fuses are an important part of the car, man. Talk about a fuse and let's look at it on your website.
We have fuses for specific vehicles. You look up the make, the year, the model, and if it has a convertible top, unique fuses for the car. And then under tools and universal parts, we have the fuse kits like you showed, just showed, where you have a complete set of fuses that'll cover several cars in your fleet. Fuses are really the gatekeeper now to the circuit. If you look under literature, we have service manuals. And the repair, instead of just disconnecting the battery, it'll often tell you to pull a specific fuse, and that'll take power away from the fuse so you can safely work on it. And the fuse can even be help you diagnose the car. Let's say you have the battery's going dead, there's some slow parasitic drain somewhere, a little light bulb's left on, or computers or sensors shorting out. You can take your multimeter and put the probes across the two contacts on the fuse, and if there's a voltage there, even just a little tiny voltage, it tells you there's current flowing there, and that's the circuit that's probably draining your battery.
Yeah, and then people replace the battery, you know, and they don't do stuff like this. You know, those little draws, they start to add up, and eventually we're eating those plates away, and it's premature failure on the battery, and it's really not the battery's fault, it's just that parasitic draw.
Right. That's going to really help you track it down.
It's a great idea. I'll tell you what, I'm going to go through rockauto.com with you for a little while. You guys take a short break, but not a long one, about 2 minutes. We'll be back with more Tech Garage presented by rockauto.com.
Tech Garage, presented by RockAuto.com, is brought to you by Pedal Commander. Make every car a performance car with Pedal Commander. B-Rod or Custom. Every build we do is a custom fabrication. And by RockAuto.com. All the parts your car will ever need.
Welcome back to Tech Garage, brought to you by RockAuto.com. Folks, it is time for our favorite segment of the show, the video question of the week.
Yeah, and this one has to do with a problem with the rear end. Let's check it out.
Hey, this is my van. I got about 150,000 miles on it. I noticed it's starting to whine whenever I accelerate and decelerate. I think it's the differential going out, but how do you open up and check it?
Well, Trey, first off, hats off to you. Making deliveries in a cargo van, that's the backbone of America, man. We love you. Now, that cargo van's the key word because that's a big echo chamber. So you're hearing a lot going on, and it's probably the differential. You're probably right. The excel and decel, that's a huge clue. Brian, you got some driveway tips you can show Trey.
Super fancy tool for you, Trey. A mechanic stethoscope will go a long, long way here. You want to check this outer wheel bearing. Go ahead, John, if you could spin that wheel.
I got it.
And honestly, you're listening for a consistent sound. It's as much about what I'm not hearing as what I am hearing, and that sounds uniform and true. There's no bearing in there grinding or a flat spot on any of the bearings that I could tell. A little bit more, John. Let's check the differential back here. No irregular sounds there. One final check.
Whoa, you're wearing me out here.
Again, sounds very consistent. And the final thing you can do is just a fluid check. Now back here, it's on the side cover. You just want to remove that access plug. I've got it loose here. Typically a fingertip check up in there. Just check and make sure you've got fluid. We do. This is pretty good. It's actually nice clean fluid. So if you had to change that and service it, use a magnet. You always want to check for fragments as you drain it. Not hard to do, and it goes a long, long way.
And Brian, Zumbrota actually sent us a differential right here, which is super nice because it's a complete
Awesome.
package. It's all here. Everything's done right, you know. This is the way to do it, Trey. If you're going to replace one, just get the whole differential. But there's some other checks, you know. You want to change the fluid too, Brian.
Absolutely. Just kind of like changing the oil in the engine. Back here, there's tremendous loads these days with the all-wheel drive, traction control systems. These are always under duress. The only thing between steel on steel grinding each other apart is the fluid. You want the right fluid, the right viscosity. If it calls for synthetic, use that. This Zumbrota cutaway tells the whole story for us.
I love it. Here's our differential now. First thing I noticed when I opened it up, you can see the toothpaste contact right here. That's awesome because they got it set up right. Zumbrota does a great job. The bearings in here, you're getting new bearings. The caps are torqued to specifications. Check it out, man. You spin that thing, it's just as smooth as ice. Your little clutches in there, your packs, your lockers, everything, side gears. You know you're getting everything right. Why do you want to just buy a Zumbrota differential? Man, I'll tell you, setting these things up is an art form.
It certainly is. If you don't have the right tools, the patience, the know-how to set lash and all that, you can really get in over your head quickly. When you think about replacing struts on today's vehicles, we've all done it. You can buy the complete quick strut assembly. It's all together for us. You don't have to transfer coil springs. Think the same way with a big project like this. This is truly from Zumbrota, plug and play.
No doubt. Look at this. I mean, we got the pinion right here, tooth contact right there. We're spinning. The only thing between that is the fluid. Now look at this carrier. You got a bearing out here, new one on your Zumbrota. You got a bearing on the other side, new one on Zumbrota. You got one on your pinion. Any one of these can give you a problem. Pinion preload, pre-lash. You got a crush collar right here. All this depth has to be set, man. I mean, I don't know about you. I've done a few of them, but it's so much easier just to buy the whole differential, put it in there, and be done with it.
A little more money, but the confidence in the repair, the confidence in the sustainability is very high. So that's what we recommend.
Phenomenal. phenomenal.
Yeah.
You got this beefy tube in here. Everything's good. You know, sometimes we get some cracks with these welds as well.
Yeah.
You got your vent hole, your whole pinion, your crush collar. Everything's done. Zambroda's doing it right. This is the way to go. And don't forget about the axle seals and bearings. I mean, putting these axles in, you're going to have differential fluid all over your brakes after so many miles or whatnot. A lot of people just knock the seals in back here. Zambroda's got the new seals and bearings. It's the bearings usually the problem that beats the heck out of the seal that causes that fluid leak.
Yeah, I'll tell you what, it is a really nice setup, and I feel like you can definitely do that. You got to make sure you replace the gasket. It comes with the kit. Be sure you do this. Again, tremendous heat back here and pressure. You got to have the gasket and a clean surface if you're servicing an old one.
Yeah, this beefy one's the way to go.
Absolutely.
What about our Mustang?
Well,
man?
that's what I was going to ask you. How's it running?
Yeah, let me tell you something. I went on that drive cycle. That was huge because there's enable criteria to meet for the computer to run that EGR. So I took it out, 55 D-cell, did what I had to do. No check engine light, no pings, no nothing. The motor's running like a top. We got that one.
I'll tell you what, not all that complex of a repair. You hear us say that a lot these days. Proper diagnosis and proper process and procedure made all the difference on that repair.
No doubt. Now keep those Facebook, Twitter, YouTube, keep all them questions coming and comment. We love them. We actually go on there, look at them, answer them. We're a show for the people, man. But we're out of time for today. So stick around for next week. There's going to be more Tech Garage. You don't want to miss it. Presented by rockauto.com.
Production assistance for Tech Garage is provided by Chapala College, located in Marianna, Florida. Founded in 1947, Chapala was ranked recently as one of the top 3 community colleges in the United States.